We will try to look at section 2.1, which is called frequency distribution and their graphs with this video. We have two objectives for this lesson. Objective 1 is how to construct a frequency distribution including units, midpoints, relative frequencies, cumulative frequency rates. And our second objective will be how to construct frequency histograms, frequency polygons, and relative frequency histograms. Here's what a frequency distribution looks like, and we're going to learn how to create it. A frequency distribution, as you can see from the slide, it is a table that shows classes or intervals of data with a count of the number of entries in each class. For example, from this table, I understand that from class 1 to 5, or from interval from 1 to 5, there are 5 data entries. That's the frequency. From 6 to 10, there is 8 frequencies. So there are 8 count of number entries. So we have class or intervals, and then the second column is frequency. The frequency is the number of data entries in the class. Frequency distribution. Now, when we look at the frequency distribution chart, each class has a lower class limit and they have an upper class limit. So the lower class limit, it is the least number that can belong to that class. And the upper class limit is the greatest number that can belong to that class. Lower limit class and the upper limit class. The class width is the distance between the lower and the upper limits of these two consecutive classes. So it's not the difference between 5 and 1, it's the difference between 6 and 1. So for the class width, you're actually taking 2 consecutive intervals or 2 consecutive classes, and you are finding the difference between 2 lower limits, or you can find the same answer by subtracting the 2 upper limits. The difference between the maximum and minimum data entries is called the range. So the range is, in statistics, it is always called the difference between the lowest number and the highest number. When we look at how to construct a frequency distribution, we have to follow these steps. Step number 1, we need to decide on the number of classes, usually between 5 and 20. Otherwise, it may be difficult to detect any patterns. And then find the class width. Determine the range of data, divide the range by the number of classes, and then round up to the next convenient numbers. Third part is the find the class limits. You can use the minimum data entry as the lower limit of the first class, finding the remaining lower limits at the class width to the lower limit of the preceding class. Find the upper limit of the first class. Remember that classes cannot overlap, and then find the remaining upper class limits. Make a tally mark for each data entry in the row of the appropriate class. Count the tally marks to find the total frequency F for each class. So after we read all these directions, now we're going to look at an example. So we have a data set here. This data set lists the second screen times in minutes for 30 US adults on a recent day. And we're going to construct a frequency distribution that has 7 classes. So we need to have total 7 classes. And then here is how much time each adult spends on the screen in minutes. We have an adult who's spending 200 minutes, or we have another one 342. We have another one just 165 minutes. So we're going to look at these steps again to construct a frequency distribution table. First thing is, we need to decide how many classes we need. It was given in this problem, the problem told us that we need to create 7 classes. And then we're going to find the class width. To find the class width, we need to divide the range of these numerical values by the number of classes. And then if you remember what range means, range is the difference between the maximum and the minimum number. So from this data set, the maximum number is 405, and the minimum number is 155. So the range of this data set is 405 minus 155, which is 250. Now we're going to divide this because we want a total of 7 classes. Therefore, this is about 35.71. Because they told us to round this to the convenient number, 35.71, we're just going to round it to 36. So this will be the class width that we need for this data set. Now, use 155, which is the minimum value, as the first lower limit. So for each class, we need a lower limit and we need an upper limit. And remember, we need 7 classes total: 1, 2, 3, 4, 5, 6, 7 classes. So since the minimum number is 155, that's the lower limit for the first class. And then we want the class width to be 36, so we're gonna add 36 to this number. So this is the next class start number, lower limit. Add 36 again and get this number. Add 36 again, get this number. Add 36 again and get this number. Add 36, get this one, and add 36, get this one. Okay, and then that's how we get to lower limits. Now, for the upper limits, the upper limit of the first class is 190, which has to be always one number less than the lower limit of the second number. So we're going to go back here. First, we just fill in this first column. And then because the second class needs to start with 191, so the first class upper limit needs to be 190. Because the third class starts with 227, so the second class needs to end in 226. So these numbers are always one less than the next following number. This previous upper limit is one less than the next lower limit. That's how we fill the numbers for upper limit. And then the upper limit is always the first class minus 1. First class is lower limit minus 1. Add the class width to 36 to get the upper limit of next class. Or as I told you, you can just do 1 minus this number, 1 minus this number, and you can fill all the numbers for the upper limits. Now we're going to make a tally mark for each data entry in the row of the appropriate class. So we're going to see how many numbers do we have between 155 and 190. So if we go back to the data set, 155 and 190. So this is 1. This is second one. And then they all need to start with 1. And then 195 is the third one. But 195 doesn't belong to this group. 168 is the third one. So therefore, we will need 3 tally marks. So the frequency will be 3. Similarly, you're going to check the all data set to see how many numbers you have between 191 and 226, and then you're going to find the frequency. So you're going to create a tally mark, and then you're going to write down the numbers of each frequency. Now, these are the expenses, like how much minutes they spent on the screen time. And then these are how many adults is within this interval. And then if we add all these numbers, we need to find our 30 adults who took the study. Check that the sum of the frequencies equals the number in the sample. That's how we construct, this is called the frequency distribution. If we go back to steps for frequency distribution after this example. So if it is not given, we need to decide how many classes we're going to need. And they told us that you usually try to choose between 5 and 20 if it is not given. And then find the class width. To find the class width, you will need to find your range, which is the maximum number and the minimum number. And then you're going to divide the range by the number of classes. If it is given, you will divide by the given number. If it is not given, you can decide any number between 5 and 20, and you can divide your range by that number. And then if it is not a whole number, you can round it to the nearest convenient number. And then you're going to find the class limits, especially the lower limits. You're going to use the minimum data entry as the lower limit of the first class. And then you're gonna find the remaining lower limits by adding the class width to the lower limits. So you're gonna just find all the lower limits by adding the class width. And then you're gonna find the upper limit of the first class. Remember that classes cannot overlap. And then in order to find the upper limits, you're gonna just look at the second row. Whatever the second row starts with, your first upper limit is gonna be just 1 minus that number. And then by using the same analogy, you can find all the upper class limits. And then you're gonna then count how many datas you have within that interval. So you're gonna make telemark, and then you will count the telemarks to find the total frequency for each class. And then we looked at this example, which the class was given, class size was given, and then we did it. Now the second objective for this lesson is determining the midpoint. Determining the midpoint of a class. You will add the lower class limit with the upper class limit, and you will divide it by 2. For example, if you remember our first class, it starts with 155 and it ends in 190. You add these two numbers and divide them by 2, and this number becomes the midpoint of the first class. Using the class width of 36, you can just find the remaining midpoints for each class. So 172.5 plus 36, this will be the midpoint for the second class. And then if you add 36 to this answer, you can find a midpoint for the third class and so on. Now we need to look at a vocabulary called relative frequency of a class. And what does it mean and how we're going to find the relative frequency of a class? It's a portion or percentage of data that falls in a particular class. So relative frequency, in order to find the relative frequency, you need to find the class frequency, which is f, and then you have to divide it by the sample size n. For example, if you have 3, if your frequency is 3 for that class, and then you have 30, so 3 out of 30 will be the relative frequency. And then if you look at here, n is always frequency times the sigma, or it's the total of frequencies. So cumulative frequency of a class, the sum of the frequency for that class and all previous classes. Cumulative frequency of a class is the sum of the frequencies for that class and all previous classes. The cumulative frequency of the last class is equal to the sample size f. Now we're going to look at an example about finding the midpoint, relative, and cumulative frequencies. Using the frequency distribution in the previous example, we're going to find the midpoint, relative frequency, and cumulative frequency for each class, and then we're going to describe in the patterns. Okay. So we already had this chart created for us. Before we learned how to find the lower limits of this data set, and then the upper limits of this data set, and then we learned how to find the frequency distribution for each class. Now, to find the midpoint for each class, we know that we need to take the first number here and 190, divide them by 2. This is the midpoint for the first class. And then we can just add, 36 to this number to find the next midpoint, because that's the class width. 36 is the class width. And you can find the midpoint for each class. Now, when we look at the relative frequency, the first class has 3 as a frequency out of 30 entries. So 3 out of 30 makes a 0.1 as a relative frequency. The second class has 2 entries out of 30, so that makes 0.07. Third class has 5 entries out of 30 data entries, that makes 0.17. And this is how we calculate the relative frequency. When we look at the cumulative frequency, so the first one, always the same as the class frequency, which is just 3. Now, we got 2 more numbers from this interval, so 3 plus 2 is 5. And then we got 5 more numbers from the third class, so we already had 5, and then 5 more we got. Now we have 10 data entries. For the fourth class, we have got 6 more entries, that makes total of 16. And then get 7 more, and that makes 23 for this class. um, Here, 23, as you see, 324. This data frequency has 2 more entries, so when you finish all the calculations for cumulative frequencies, the last line is going to show you your sample size. The remaining midpoints and relative frequencies and cumulative frequencies are shown in this expanded frequency distribution below. So this is the class which shows the screen times. And then this is the frequency, how many adults we have for each minutes interval, midpoint. Relative frequency is portion of adults, and then cumulative frequency. There are several patterns in this data set. If we go back here, and then we look at here, we can look at relative frequency calculations, cumulative frequency calculations. But for example, most common range for the time is 299 to 334 minutes. So let's see. Yeah, we got more adults in this class than any other class. We got 7 adults who are watching between 299 and 334 minutes. So we can say that the most common range for this time is 299 to 334. Also, about half of the times are less than 299 minutes. Okay. Now, we're going to look at the graphs of the frequency distributions. So, frequency histogram. It's a bar graph that represents the frequency distribution. The horizontal scale is the quantitative and it measures the data values, and the vertical scale measures the frequencies of the classes. Consecutive bars must touch each other for frequency histogram. Class boundaries. Because consecutive bars of a histogram must touch, bars must begin and end at class boundaries instead of class limits. The numbers that separate classes without forming gaps between them. So we're going to now construct a frequency histogram with the same data set, and then we're going to describe their patterns. So we already created this chart before. We have the class lower limits and upper limits, and we have the frequency, and then we have the midpoints, relative frequency, and cumulative frequency. Now, how are we going to construct a frequency histogram here? First, we're going to find the class boundaries. So the distance from the upper limit of the first class to the lower limit of the second class is 191 minus 190, which is 1, and half of this distance is 0.5. Therefore, the first class lower boundary is 0.5 less than this number, and then we're adding 0.5 to this, so you are getting 190.5. So we're subtracting this number from this, and then dividing it by 2, and then we're just expanding the class boundaries. This one is as 154.5, 190.5. All these are expanded for class boundaries. You can mark the horizontal scale either at the midpoints or at the class boundaries. Both histograms are shown below. So this one with the class midpoints, and then these are the class midpoints for each bar. And then it shows us how many values we have for each midpoint. And then this one is with the boundaries. So start number for each bar and then the end number. And it tells you the frequency for each one. And then when we come back to the observations or patterns, we can determine that 2/3 of the adults are spending more than 262.5 minutes each day using their cell phone. 262.5 is this one. And then that's just like 6. And then if you look at more than this number, 6, 7, 4, 3, if we add them up, that's about 20 adults out of 30. That makes 2/3 of this population. Frequency polygon. It's a line graph that emphasizes the continuous change in frequencies. When we have this chart again, if they ask us to draw the frequency of polygon for the frequency distribution in this previous example, this is how we do it. And then first we had this, and then it jumps over here, and then it comes back here. The graph should begin and end on the horizontal axis. So extend the left side to 1 class width before the first class midpoint, and extend the right side to the 1 class width up to the class midpoint. You can actually construct a frequency polygon with some technology, and then here in the slides they showed you how you can use it by TI-84 calculator, but there must be other technology to do this. Relative frequency histogram has the same shape and same horizontal scale as the corresponding frequency histogram. The vertical scale measures the relative frequencies, not the frequencies. Construct a relative frequency histogram for the second example. From this graph, you can quickly say that 0.2 or 20% of the adult screen time is between 262.5 and 298.5 minutes. And then cumulative frequency graph, it's a line that displays the cumulative frequency for each class at its upper class boundary. The upper boundaries are marked on the horizontal axis, and the cumulative frequencies are marked on the vertical axis. I don't think that we need to pay a lot of attention to how to construct this, but it might be a good idea to understand how we can create this. And then there's a technology to create. If you have the TI-84 plus calculators, these slides are explaining you how you can create them. But I think learning how to do it using Excel is even better than creating it with calculator. And then this is all for 2.1.